Hey there! If you are a returning visitor to the channel, you might have noticed the lack of Raspberry Pi related videos lately. Well, let's say I had my reasons, and I will explain it shortly. So if you're interested, let me show you what I've been working on lately. And also, before we begin, if you're new to the channel, my name is László Mersal, and this channel deals with home automation, home networking, and with related stuff like DIY electronics and even a little bit of 3D printing. Anyway, let's continue. Let's see what I have in store for today. So here we go. This is what I wanted to show you. The next generation of my Raspberry Pi cluster. So if you're not familiar with the concept or haven't seen the previous video, or actually the video about the previous version of this cluster, I started building one just for fun, and one of the clear design goals was to make it portable, so small, powered by a single power cord, and something I can carry to hackathons or LAN parties, or just, that was the clear goal. And there were some specific requirements from my part also, like wired communication between the nodes, and extensibility, proper cooling and whatnot. So in the meantime, while I was tinkering with it, with the previous version, I made some discoveries, I learned some lessons. I actually almost blew up the whole thing one time, but that's another story. And I just realized that having such a cluster is quite a nice opportunity to migrate my smart home's heart from the biggest server to this cluster. So everything I'm running in my smart home is pretty much runnable in Docker. And these Raspberry Pis, especially with the Raspberry Pi 4 with 8 GB of RAM, makes an excellent Docker host. So I thought to myself, what the hell? This thing barely pulls any power, and it can run a lot of stuff. So why not make a more stable, more versatile version that I can use? So what I've made is to make it more modular. As you can see, you can remove these brackets, and actually you can screw Raspberry Pis to them. Also, this is the new power distribution module. I will show it in a few seconds or few minutes. This is an SSD, which acts like kinda shared storage. Obviously, it has to be connected via USB to one of those Raspberry Pis. So at the moment, this node acts as a storage server, and because of the gigabit connection, the other Pis and the future Pis can access storage from that. Also about the power supply. This is an ATX power supply, and I had to switch to this because the first version was running with this power supply, which is a cheap Chinese Minwell clone, which provides a lot of amps and 5 volts. But unfortunately it turned out to be not really stable. Turning off the power supply with the Pi still on, still connected, produced some interesting ripples, and it was scary, to be honest. And that was the point when I realized that I could just kill all the Raspberry Pis with it because of those ripples, because of the extra over voltage. So then I thought to myself, what could be the possible replacement? I could go with a Minwell power supply and pretty much continue with the same idea, or turn to something totally different. So an ATX power supply is quite a smart thing compared to one of these, because it has not only 5 volts, but it has a 12 volt line, which can be used for the cooler and for the gigabit switch. And of course it has some extra features like whatever safety circuits you can think of, because these ATX power supplies are meant to serve power for expensive PC parts where a motherboard can cost more than the whole cluster. So these are much more stable, much more safe to use than these cheap power supplies. So at that point I realized that whatever I had in mind, whatever I have planned with the 5V only power supply will no longer work. Original idea was that there's the input of 5V and then I do a conversion to 9.6 I think, and then use the cooler undervolted to 5V, because that's a 12V cooler, but you can run it with 5V, and yeah, it will work. It will spin slowly, it will produce no noise, but still moves the air from up to down through the Raspberry Pi's heat sinks. So this should be an adequate cooling solution, and that was the original plan. But now with the 12V possibility, I rearranged the circuits a bit, and now instead of using a step-up converter, I use a step-down converter to turn the 12V into 9.6V, and of course I could use the whole 12V to power the cooler. Unfortunately, just having the full voltage on the cooler means it spins too fast, it produces noise, and I wanted something that is completely silent, or at least as silent as possible. So I ended up having 100 ohm potentiometer on the power module, so I can just use it to change the speed to a required level, to a level which still provides adequate cooling, but will not produce that much noise. So before I take this out and show you, just let me, as a quick reminder, show you the previous power distribution module. So here we go. Yeah, this was the previous prototype, but actually I deemed it quite stable to use it for the cluster. So sadly the problem with this one was that basically this whole thing is a single circuit, and because of that, if there's something unexpected like the mentioned ripple, or for example kickback from the cooler, so I thought to myself, okay, technically it is possible that when I stop the power, I cut the power from this module, the still spinning cooler will act as a generator, and much higher current than 5V will flow backwards. So I experimented with adding a Flyback Diode and whatnot, but then I just realized once again that ATX power supplies are much more elegant, because they have separate lines, and when you are using it, you pretty much trust the power supply to handle stuff like that. Because if you open up a PC, you will usually see that these coolers can be, and usually are, connected directly to the power supply one way or another. Of course they can be connected to the motherboard and stuff like that, but it's totally safe to connect them to the power supply. So a power supply should be prepared for that. There should be a Flyback diode in there and whatnot. So this was the story behind this whole thing. Also, I really like this modular idea. So just replacing the threaded rods, I can make it higher. I've been also experimenting with the idea of making it wider. to add more Raspberry Pis. It actually was all up to the power supply. The only problem with this power supply, which is an FSP power supply by the way, is that it can only provide like, I think, 20 amps on the 5-volt line. Yeah, so it means no more than roughly 6 or 7 Raspberry Pi 4s, which is not a lot. But it can provide a lot of power, a lot of amps on the 12-volt line. So at some point, if I start adding more Pis, I can use a step-down converter and basically split and turn some of the 12-volt connections, the 12-volt lines, into 5-volt lines for the Raspberry Pis. So that opens up a lot of possibilities. Anyway, I'm talking a bit too much about this now, so instead just let me shut this down, let me take this little guy out, and then let me show you what I've made. So this is the power distribution module, and first of all I would like to emphasize that this is only a prototype. So it's on a proto board, but yeah, for now I consider it somewhat complete, at least ready for some testing. So as you can see, the parts are not really that much. We just have a few wire terminals here. This is for the custom ATX connector I have made. So I'm just using the 5 volts and the 12 volt lines, and those are marked with yellow, I mean the 12 volt ones, and a few grounds, and also these are soldered together. So these two cables are for the power button. If I would like to add something like a toggle button for the whole thing, then that would be connected here, but since the power supply already has its own power button, then well, no need. So I just solder those together. It's like always on. Regarding the module, this is the potentiometer I've mentioned, and it is responsible for changing the voltage between 0 and 12 volts on these connectors, which are for 2 coolers. Right now I'm only utilizing one, but who knows, maybe later on. This little board added on top, this is the step-down converter. So it takes 12 volts coming from this cable and simply tunes it down, and this is the output. This is where I've connected the barrel jack cable of the gigabit router or switch, sorry. And finally, these are the USB connectors. Compared to the previous version where I used single connectors and added some awkward solution, this is much more elegant, not to mention much more stable, because this whole thing was a little bit wiggly, and this is more stable. So as you can see here, there are 8. On this one there's only 6, and that's because the mentioned amps limitation of the 5 volt line. But again, I could make a similar module, add the step-down converter, and set it to 5 watts as the output. Then I could add a lot more. Okay, so instead of showing this, or actually the back part, I could just go on and show you a diagram, a wiring diagram, and yeah, that's what will I do now. So first of all, just for comparison, this is the schematic for the old version of the power distribution module. So this is the part where I could connect the step-up converter with the output for the network switch here. Then there was the single 2-pin screw-in terminal for the 5 watt and the ground. There was this power indicator LED with the necessary resistor. Then there were those 2 fan connectors. There were these USB type A connectors lined up, and the 2, or actually 1 header. The other one is just a fake for stability's sake, for holding the shield. So, and this is the shield with additional 4 USB connectors, and of course the header pins. So for what it is, this was a bit complicated. I mean, obviously there could have been a better solution. And now this is the new version, and it is much cleaner in my opinion. So right now, instead of having the ATX 24-pin connector soldered to the board, it is just a screw terminal with a custom cable ending with the ATX connector. That isn't necessary because for the proto board I couldn't really attach or solder the ATX connector. It has different pin distance than the usual pin distance for these proto boards, so that was a temporary solution. On the final PCB that I'm planning to order at some point, obviously the connector will be soldered, so there will be no need for that extra cable, converter cable. Next, these are the pins where I can solder the step-down converter to, and this is the output of the voltage or the power coming to the network switch. Now here's the potentiometer that is responsible for controlling the speed of the fans, and these 2 are the fan connectors. And finally, on the separate 5 watt line, so basically here, by the way, here are separate grounds and separate pluses for the, VCCs for each major components. So for the 5 watts, this is 5 watt VCC, this is ground, and all the double USB connectors are just lined up nicely. And actually, given with a larger proto board that I unfortunately don't have at hand at the moment, I could just go on and keep adding more. Obviously, for the final PCB, I think I will stop with 8 right now, but who knows? It totally depends on the PSU. Right now, it's 7 is the ideal number of USB connectors, so even 8 is a stretch, but for that I should drive 8 Raspberry Pi 4s to full power to actually hit the limitation of amps on the PSU. So probably 8 could work also. So what next? With this schematic, with this design, the whole thing works quite reliably. So that means I can get back to using the cluster for what it is and start making Raspberry Pi related videos once again, which is good news. On the other hand, besides having this prototype, I will start designing the final PCB, and yeah, at some point the prototype will be replaced with a custom PCB with all the parts properly soldered to it. So that's it. I think this is the only thing I wanted to tell you about this project and the state of this project right now. I hope you found it useful. If you have any feedbacks, ideas, obviously I'm glad to hear about those, so use the comments, and otherwise hope to see you soon, next week with another video. See you around, take care, bye. You're still here. That's good, because that means you kinda liked my video. If so, feel free to check out these other videos too. And if you're new to the channel, please consider subscribing. That helps me a lot. And yeah, if you click the bell button, you will get also notified about new videos.